Hi, this is Richard C. I'm a math tutor here at Wyzant, and I'm answering a question submitted by a student. Okay, so this has to do with exponential growth. The general form of the exponential is y equals a times b, and here I'm going to use t. It often is time, so I think it's more convenient to use a t here. A is the starting amount because when t is 0, this term goes away. B to the 0 power is 1. And so A is the starting amount, Y is the ending amount, B is the base. And we're going to talk about the base in a second. Okay, so for this particular problem, let's figure out what these values should be. So we'll leave Y alone. The starting amount is 2,000. And it's going to double. And so that determines the base. The base is 2. How often does it double? It doubles every 30 minutes. And we're going to use minutes here. Now, t, it's going to be t over 30 because 30 minutes later, if t is 30, then this exponent becomes 1. See, so 30, if t is 30, it's 30 over 30, which is 1, which means it will double. It will be 4,000. If t is 60 minutes, it will quadruple. It'll be 2 squared, you see, because 60 over 30 is 2. So 2,000 times 2 squared is 2,000 times 4, so it'll be 8,000. Okay, so that's how you come up with the base and with the exponent. Okay, so now we're ready to answer the question. So for part A, we want t is 40. So y would be 2,000 times 2 to the 40 over 30. And we just put that into our calculator. So 2 to the 4 thirds. I get 2.5 something, 2,000 times 2.512 approximately. And that's going to give me 5,040. Let's round it to the nearest bacteria. You can't have a partial bacteria, so we'll round it to the nearest bacteria. So 40 minutes later, you're going to have 5,000 of these. 60 minutes later, you'd have 8,000. Okay, so that seems about right. Certainly you're going to have more than 4,000 because 30 over 30 would give you 4,000. 40 over 30 would give you a little more than 4,000. So that makes good sense to me. It's always good to ask yourself whether the answer is believable. If it's not believable, you know you made a mistake somewhere, you can go back and check. Now we have to be careful here with the 7 hours. This 7 times 60 is 420 minutes. So remember we're measuring time in minutes here. T is in minutes. So 420, that's a 2. My handwriting needs a lot of work. Okay, so we're going to go 2,000 to, so raised to the 420. There are going to be a lot of bacteria here, that's for sure. So 2,000. So let me evaluate that. So 2 raised to the 420 divided by 30. That gives me 16,384. Woo! Times 2,000. 32768,000. Ooh, okay, that's a big number. Put in our commas. So we've got 32.8 million bacteria after 7 hours. 7 hours is going to be 14 periods, 14 doublings. That's another way I could have done it. 2 to the 14th is 16,384, so that matches. So it'd be 2 to the 14. Okay. So those are your two answers. It's nice to see the effects of exponential growth. Exponential growth is used quite a lot in biology problems, growth and decay, and also in financial problems, growth and decay, exponential growth and exponential decay. Turns out that exponential functions model a lot of natural science phenomena, and they can also be used to model investments. So if you're interested in either of those topics, you should pay particular attention to exponential models. Okay, so that's it for this problem. I'll see you again next time. Bye-bye.